Hey there, welcome back to Coding at Home with Code Hub. Today we're going to be talking about the last of the. Yeah, we'll bring it back here for a second. We're going to be talking about the last of the logical operators. I'm sure you'll be happy to see the end of it. Of course, you'll never see the end of any of these things because you'll use all of these things throughout your programming career, and it'll let you build much more interesting apps and functional apps as well. If you haven't had a chance, and I know you haven't because nobody has, feel free to fill out our survey. We'd love to figure out where we go next with this. I'm thinking something with augmented reality once we finish up with Everyone Can Code Puzzles. But I want to hear from you as well to make sure that we're generating some content that's kind of interesting to you that you're going to try to use around the house. So today's thing is going to be a BuzzFeed style quiz. We're going to find out what type of animal are you. So let's go over to our iPad for this. All right, so I'm going to open up Playgrounds. Now this is in the Code Hub Answers playground that we were playing around with a little bit yesterday. I'm just going to run it. Instead of showing you the code, which might ruin the surprise, I'll run the code. It asks me my name. That one I usually get right. I hit submit. Now, I'll often miss and I'll forget and I'll hit the stop button. That stops the running of your code. So you want to make sure that you're hitting the submit button over to the side of this text. So it says answer some questions. I'll tell you what type of animal you are. Are you house trained? I'm pretty sure I am. If you aren't house trained, well, you could hit this toggle again and then go back to false. So we'll hit submit. Remember, this is a Boolean value here. If I threw a ball, would you chase it? Well, probably. So let's say yes to that one as well. I'm a dog, it turns out. Now, if I go and run this a few other times, there are a couple other options of answers. If I say, actually, no, I'm not house trained, but I'd still chase the ball, hit submit. Turns out I'm a wolf. So let's look at the code that I used to build this very, very simple quiz. So if I tap over here on the side, you can see the little arrow. It'll bring out my coding view. So I have not a lot of frills here, but we have the little setup where we ask for our name. I set up a little prompt that says, answer some questions and I'll tell you what type of animal you are. And then I show the question, and then after each question, I have a variable where I ask for input from the user. So ask for bool, and that gives me that little interface over there that we saw with the toggle. So the first one is house trained, and it's a Boolean variable, and we can see that it was false in this last running of the code. The next time I show the next question, if I threw a ball, would you chase it? I have a variable called would chase ball. Now, you notice that I've tried to name these in ways that are going to tell me what it is I'm doing with this variable, right? So I'm storing inside here, the answer to is house trained. In this case, I answered false, so it's false. I'm not house trained. If I were trying to capture the other, I might try to name it is not house trained if by default it was true. It's just a way of letting me read it almost like an English language sentence. Same thing with would chase ball. This is going to answer the question, well, if it's true, I would chase the ball. If it's false, I would not chase the ball. And then here you can see, just for my own sake, I kept a list of the different emojis that I'd return. So I have a lion, a cat, a dog, and a wolf. So I use some of my logical and operators here. So I check to see if I am house trained and I would chase the ball. Well, that sounds like a dog. Otherwise, else if I'm not house trained and I would chase a ball, I'm a wolf. So I tried to handle the canine family answers first. Next up, I say else if is house trained and wouldn't chase the ball, I'm a cat. And then otherwise, if is not house trained and wouldn't chase the ball, I'm a lion. So this is a fairly simple BuzzFeedy style question. Now it can get a lot more complex. The first version that I threw together, I did just in the normal text page, where I asked a few more questions asking if you have whiskers, if you have a horn, if you like water, are you afraid of heights? Is your brain the size of a walnut? You can probably guess where I'm going with that one. And then this is the logic that we built up here. A lot more complex. And you'll notice that up till now, we've only used two different variables with a logical operator. So if we go back to my homework quiz for a second, I'm using is house trained and would chase ball. So those two. Now, when you add in a third, and you say is house trained and would chase ball and something else, all three of those variables need to be true for this code to get run. So let's go back to our text. And this is all of our kind of value gathering code here. And then down here is where the real meat and the brains of the program is. So this is where we try to figure out if someone's a whale, if they're a dinosaur, if they're a duck, or a turkey is kind of the hidden special one. So you can see there's lots of different ways that you can write this code. There's lots of opportunities for debugging in here. When you run the quiz, you're going to have to test out all the different answers to make sure that you can get all the different types of answers. But it's something fun to play with. I'll post the code for both of these. They're not very exciting. They're pretty simple, but I'll post the code for both of these either on the Swift Playgrounds feed or in the description of these videos. So that's kind of wrapping up logical operators for us. So now that means we move on to the next chapter in the Everyone Can Code Puzzles book. So I'm going to open up the books application and my Everyone Can Code Puzzles book. So this is where we finished off using that not operator. And we use that kind of nicely in our quiz in conjunction with a logical and operator. So there we go, talking about the last chapter. So now we've moved on to chapter 9 and while loops. So you remember way back when we covered for loops pretty early on in this course where we talked about doing something a set number of times. We would do for I in 1 ... for. It would run the loop 4 times. It would execute that code 4 times, which is kind of handy when we're dealing with the puzzle world of Byte because we can kind of count out the number of tiles that Byte would be able to jump to. Well, with a while loop, we're going to deal with situations where we don't know how many items we might have. So this is a great example of the paint 50 strokes. You wouldn't say, all right, well, I'm going to go paint the room for I in 1 ... 50, because what happens if you need more strokes to paint the wall? You'd probably want to say something like they give the example here. Listen, paint it until there's no more unpainted space on the wall. Another good example might be if you're being asked to do the dishes and you say, all right, cool, well, there's 4 of us. We've got 4 dishes. For 4 dishes, I'm going to wash them. Well, if someone else happened to dirty another dish or maybe there was one less dish, you could use a while. You'd want to use a while loop to say, hey, while I don't have any clean, while all the dishes aren't clean, or while I still have dirty dishes, I need to keep cleaning the dishes. Okay, so this is a good one. I do like these examples, and I haven't given you the task of doing this yourself, but it is interesting. And at the beginning of each one of these chapters, they ask you to go out into the real world and find examples of for loops and variables and while loops. This is kind of interesting. I recommend if you can get outside a little bit to go find examples of while loops. Maybe it's raking your yard. Maybe it's bouncing a ball off the wall. I come up with a few examples of while loops you might see around the house. All right, so we've got a few playgrounds to go through. We're going to go jump into Learn to Code 1. There's a while loops chapter. I really like the introduction in this one. It gives a good example of how you would use a while loop and why you would use a while loop. Now, just because we have this new way of doing loops doesn't mean that you throw for loops away. This is just introducing you to another tool in your coding toolbox. So let me open up Learn to Code 1. All right, I'm still on using the not operator because remember we were doing that debugging session yesterday. So let's go over to while loops and tap on the introduction. Okay, are we there yet? So I really like this example as well. The example of hammering a nail, like painting a room, like doing the dishes. You're not going to stop just because you've hit the nail 4 times and said, oh, that's good enough. You want to continue hitting the nail while the nail is still sticking out. So this is what a while loop looks like. It's a little bit like an if statement. If we replace that while here with an if, it's the same thing. This is a condition that we're checking. And if this is true, we run this code. So you can see, so once nail is sticking out, turns to false, hammer nail stops running. So let's start coding. Now the nice thing about these loops is that we won't have a lot of those kind of oddities that we saw in some of our other playgrounds where we had a loop that would go 4 times or 8 times, or maybe we changed it to be more times than originally was in the loop. And then we saw bite or hopper or blue almost walking off the edge or walking into a wall or just performing some extra actions. Now we can start to test on conditions and say, hey, look, when I reach the end of what it is I want to do, this is the condition I expect it to be in. That's when I want you to stop. So we can see here we've got a goal of using a loop to keep moving while not on an open switch. Okay, cool. So these all look like closed switches. In fact, if you look, we're starting on a closed switch. Cool. So we've got a condition here. Now we had some, if we tap here, we had some variables that would give us that state, because what happens is every single time Hopper steps forward, it's the same thing that happens with the conditional code that we gave an example of a couple days ago. Hopper evaluates the whole scenario and says, hey, am I on a gem? Okay, I'm not on a gem, so is on gem is equal to false. Is on a closed switch is equal to true in this case. Is on open switch is equal to false. So let's go down here and let's look. We have a bunch of conditions available to us. Is blocked left, right. Is on closed switch. Well, that's what the explanation up here is telling me I need. So we're going to choose a Boolean condition for our while loop to determine when it will run. Now we have to add commands to the while block, which is basically just anything between these braces, to toggle open all the switches. Well, how would we do that? Well, we know how to toggle a switch. We actually just call toggle switch, right? Now, if we try running that, let's try running that. Okay, oh, we toggled the first one. And then guess what happened? So we'll actually step through it to see what happened here. So if I step through my code, we start out at the top, we evaluate the condition, we need to toggle the switch, we go back to the top, and we evaluate this condition again, is on closed switch, and we are not on a closed switch, so that's false. So we jump out to the end and we're done. So we need to also move forward inside this block too, right? So we get to the next closed switch. So let's drag over here on the autocomplete bar, hit move forward, and let's try running this code. In fact, I'm going to step through this code again just to watch it run. All right, so we get our tiles generated. There we go. We evaluate again. We're on a closed switch. We toggle it. We move forward. Next run of the loop. We toggle. We run forward. Now this will keep running so long as we have closed switches in front of us, one tile in front of us. Perfect. So not bad. 2 lines of code, 3 lines of code, and we're done. So it looks exactly like if statements. In fact, they even call out the parallel to it there. So hopefully this seems pretty familiar to you. So we're going to hit next page to go on to the next page. Okay, creating smarter while loops. All right, let's see what we get out of this. So now what we're going to do is we're going to use a while loop and an if statement to open all the switches. So we're going to make our while loop even smarter, just like we've done with for loops. We can write code inside that block that gets pretty sophisticated. So let's see. So it's saying to solve this one, we'll need a while loop to toggle every open switch, open every switch along the 3 platforms. So we've got these 3 platforms. We can see portals at the end, so we'll get portaled back to the beginning of the next platform and then to the next. So we can't simply use the condition is on closed switch because this one's on right now. So we would stop immediately. So now we have to apply a little bit of logic. We need to try to solve this puzzle and figure out what it is we need to write for this puzzle to be solved. So let's start out by adding our while loop. So we have a while loop right there. I'll tap that. So let's see. We need to figure out what condition we want to be on. What condition we want to have be true until the very end where we want it to be false. So let's see. And it says here, add a condition to make our character continue moving forward until reaching the end of the 3rd platform. Well, that's here. Well, in this case, we're not on a portal and we're not on a closed or open switch. That's one way of doing it. So let's try it out. Let's see. So we're going to say while the condition is, so while we're not on, and remember we'll use that not operator. So we'll bring up the keyboard. So while we're not on a closed switch, and then we'll use the and, because we want all of these things to be false. And actually, do we want to use and? Let's try it out anyway. And we're not on a closed switch. Sorry, open switch. I know what I'm talking about. And not on a portal. But we don't have a portal to pick here. So what will we do here? Well, we could try running this and try using a similar strategy to what we had before. Now it's asking us, hey, in your while loop, use an if statement to toggle only closed switches, not open ones. Okay, so we'll say if we're on a closed switch, those are the only ones we want to toggle. So we'll say if is on closed switch, toggle switch. And now, regardless of whether we're on a closed or open switch, we want to move forward though. So let's move forward outside of our check. How's that looking? Will we try that out? Let's just imagine us moving forward the first time. So while we're not on a closed switch and not on an open switch, okay, well, we should get here. We're not on a closed switch, so we'll skip here. We'll move forward. I have a feeling this may not work, but here, let's try running it. Let's try stepping through our code. Okay. Cool, we're moving forward. Okay, bummer. We stopped right away. So that condition isn't working for me. It got me off the first tile, but it's not going to solve the puzzle for me. So let's see. Now, one way we could do this, we could go back and implement a for loop and say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times we're going to go through this loop. But let's try to solve it with a while loop. So we'll look at the hint. So while my character is not blocked, check for a close switch and move forward. Oh, that's a good hint. All right, so while we're not blocked, and then let's not check if we're on an open switch or not on an open switch. Let's see what other hints, because we have more dots here. So let's check out the other hints. Okay, so one approach is to move forward while your character is not blocked. We use an if statement to check whether or not we're on a closed switch, and then we would toggle it. And then we have the solution. So you note that they said one solution is to do it this way. There are a number of other solutions we could try to come up with here, but let's try running this code and see what happens. All right, so Hopper's going to go off. Hopper's not blocked. Hopper checks to see if they're on a closed switch. They were, so they toggled it again, and then they move forward again. They're not on anything, so they just zoom through the portal. They checked that they found that they were on an open switch. Open switch again, so we're just moving forward into the portal. Out the other side, checks to see if we're on a closed switch. We're not. Now we are, so we hop. Checked again. Okay. That was a good idea, because at the end, of course, we are blocked. There's nothing to save us. There's nothing to send us back. So that's not a bad approach. It would be interesting to figure out what other conditions might be present here to help us out. So we don't have the is on portal check. But what else? What other conditions could we use here to check and see how to solve this puzzle? What needs to be false for us to solve this puzzle? That's a good exercise for you to do a little bit later today. Now we're going to go on to the next playground page, and we're not going to complete it today because it's a little bit more in depth. So if we go tap on the title here, the next one we're jumping to is nesting loops. And in fact, you know what? We're going to save that for tomorrow. So tell you what, let's go to choosing the correct tool. Because nesting loops is interesting because we can see the real power of these loops. But it is a little trickier, and it takes a little bit more time to wrap your head around. So I really want to give you guys plenty of time to let it sink in and really hit home. So let's work through choosing the correct tool. The nice thing about following Everyone Can Code Puzzles is they give you suggestions for sort of representative playground pages to go through, but all of these playground pages are actually excellent. So they're all worth doing. 4x4, turned around, land a bounty, random rectangles, and you're always right. Totally worth going through to try to work on your while loop skills. So we're going to do choosing the correct tool. So the goal is to choose the best loop to collect all the gems. Okay, so the puzzle has 6 gems and a simple pattern for your character to follow. Well, it looks like a sort of diagonal pattern, right? So we're going to kind of go forward, turn left, go forward, collect the gem, and then turn right, and then do that again. In fact, we have that written in code here, right? We have a function called turn and collect gem where we move forward, turn left, move forward again, collect the gem, and then turn right. Okay, cool. So we could use a while loop to keep moving while nothing blocks the way. That's cool. We could use a for loop like it mentions. So let's try using a while loop, because that's what we're practicing right now. It does mention up here that sometimes deciding how to solve a coding problem is just a matter of which option feels better to you. You might like for loops better because you understand them better. You feel like you understand them better. Or you might say, actually, do you know what? While loops make a ton of sense to me. That's what I'm going to use in this case. It doesn't matter. But when you do have those debugging sessions like we had yesterday, it's useful to have an opinion about, well, why did I pick it? Oh, well, I like those. I prefer those because I get them more. So when you can explain it to your friend out loud, it helps a lot in letting you think through how you're building your program. So because we're practicing, let's use a while loop. So while we're not blocked, so we're going to use the not operator. And this is where this comes in handy. So while there's not something in my way, I'm going to run this code, because what's going to happen at the very end? I'm going to get here and I'm going to get stuck because I'm going to fall off the edge. So I'm considered blocked. So my code is going to be basically, well, they've kind of done it for me here. So if I move forward from here, turn left, move forward, collect the gem, turn right, I think that this is going to kind of do it for me. So let's go find our turn and collect gem. That's where we can call it. Let's try running our code. And we're going to step through this one so we can see it jumping around into the loop, out into this function, and then back to evaluate whether or not we're blocked. There we go, into our function. We're moving forward, turning left, moving forward again, collecting the gem, turning right. Now we go back and call our function again. Nice, we're collecting the gem into the portal. Excellent, we called the function. So it didn't say that we were blocked. Because you see this, what's happening? You might say, well, wait a second. Hopper's actually blocked there when she's facing forward. But what happens is we wait for this function to complete. Then we come back to this while block. Then we go back and ask again, hey, am I blocked in the current state I'm in? So temporarily that is blocked is true in here. But it's not till we get back out of here and exit back out to say again, hey, I went through the loop. Am I blocked? We always wind up facing forward with nothing in front of us until the very end. So that's how we're solving that particular puzzle. Now, if you were going to do the same thing with the for loop, and this is nice. This is an example that you saw the hint here. If we tap on this, the hint of reusable. This is really nice reusable code, because you look, the code that I actually wrote were these three lines here. While I'm not blocked, turn and collect gem. That's really nice when you can write code that simple and just and have it run. Now, it took a bit of work to figure this part out. So let's try solving this with a for loop, just for kicks, to see what the both of them look like. So how many times are we going to do this? So let's see. We had a gem there, so 2, 3, 4, 5. Is it 5? Let's try 5. And we'll try running the same thing. We'll try using our turn and collect gem function. So what I'm going to do is I'm going to use comments to not run this code. So what you can do with comments are really handy is you can drag down, see over the C here. If you drag down and again, now my code is turned green. I've also got a little red arrow, but I'll ignore that for the time being. That means that this code is not going to get run. And Swift is looking at this code now and ignoring this line. So that's why it's giving me a little red arrow, because it sees a parentheses in here, but it didn't see the opening one. So let's go down to the next line, and we're going to drag on the C again and add 2 more to create a comment. And we're going to do the same in front of this brace. So what we'll do is we'll drag down we'll create a comment, and actually I'm going to add that back in so that way I know that this is my code here that I commented out. So this is what was running, and this is what's going to actually get run now if I hit step through my code. This is really useful, and we saw it in the quiz with conditions page, or the homework quiz playground page. I left a comment with all the different values that could be returned as a result of the quiz. That's a note for me, so that when I'm writing this code, or someone else, if they're looking at my code, they can look at it and say, oh yeah, okay, cool. This is he's actually explaining a bit about this code here, or he's giving a sort of very quick visual of what the results could be. So let's try running this code. This is the for loop, not a while loop. So let's try running that. Okay, cool. We're running it our first time. We're running it our second time, and immediately I can see that we're going to have a problem here. In we go. We collect our next one. So the while loops, you can see, maybe require a little bit more abstract thinking, because instead of just saying, hey, run this code 5 times, you can see that with the while I'm not blocked, you have to kind of evaluate where you are at the end of every single run of the loop. So let me see. Let me change this to 6 so we can get this puzzle to work with our for loop. There we go. We're turning and collecting the gem. Whereas, yeah, it's very clear that, look, I'm going to run this 6 times regardless. There's no conditional in here that gets me out of this loop. Whereas this one I do. This requires a little bit more thought and planning ahead to say, well, what state do I want to be in when I'm done? Because we talked a little bit about that in our little presentation, that video that I posted the other day about decision making, where every time Byte stepped on a new tile, Byte would say, hey, is there something in my way? Am I on a gem? Am I on an open switch? Am I on a closed switch? And it would set up all the different properties that we could then ask, hey, what state am I in? Am I on a gem? Cool, so that was choosing the correct tool. When we come back tomorrow, we're going to play around with these while loops a little bit more. Like I said, they do require a little bit more planning ahead. Sometimes it might even help to write it down on paper or sketch it out what it is you want to have happen. They have some really good examples of that in the book, of sketching out your thought process. And we'll cover those tomorrow. But until then, we'll see you.